Welcome for the Friday seminar this week. It's a real honour to be able to introduce Juan Frausto Gonzalez, who has completed a lot of work with the JKMRC students to enable everyone to go on a field trip to Mexico. This has been a long time coming, this kind of student trip. When I was a PhD student, a lot of people were talking about what happened in the past with PhD students, and there was a big encouragement to go on site. And I think this is the product of those discussions that happened over many years. And so thank you to Juan, and thank you to Professor Audits who's in the audience, who also motivated a lot of the students to contact the various contacts on mines internationally to get the ball rolling on the student trip. So thank you for being in the audience today. So Juan is going to present on the three mines that were listed, and there were 5 students from the JK who worked on those mines. So it was Juan, Gersh, and Erica, and Herman, and Kate that went to the 3 different mine sites. So you're going to present on behalf of those people, and then also go into more depth on one particular mine, where there's been some really interesting results in regards to fine screening and cyclone operation, and how that relates to the flotation recovery. So it should be a really interesting presentation. I'll just introduce Juan quickly. So Juan got his Bachelor of Chemical Engineering and a Master's of Science in Sustainable Practices in Mexico, and then spent 9 months in the Peñoles zinc electrochemical plant in the acid roasting area as a supervisor, and then moved through to the Peñoles Research Centre for 4 years. So he's got quite a lot of experience before he contacted us at the JK to do a PhD here. And I was just looking back through my emails from when he contacted us, and it was great to see he kind of contacted us, and we didn't have any funds to be able to support him, but he went for a scholarship through the Mexican government, and was able to come over and is doing a really interesting PhD that he's going to be talking a bit about in today's presentation, because the work that he was doing over there is so related. So yeah, it shows the great initiative that Juan has, and the ability to kind of progress things, which he showed in this PhD and then also in this site trip in organising it. So I'll hand over to Juan, and we can start the presentation. So.
Thanks for that quite long introduction, Grant. Hello, everybody. As Grant mentioned, my name is Juan Jose Frausto. I'm from Mexico. Today I'm presenting on behalf of my mates who traveled with me to Mexico, what I like to call the Suicide Squad.
Juan,
Yo.
just speak up a little bit.
Sorry. Sorry, Alex. I'm presenting in behalf of my mates, Erica, Herman, Yogesh, Kate, and Mario Corona. He's a graduate student from the University of Guanajuato. He's a PhD there, working full-time as a professor. And also on behalf of Angel Sanchez and Roberto Zarate, who belong to the Research Center of Peñoles in Mexico, and help us to work out all the problems and to process everything in Mexico in these mine sites. Right, so what we're going to see today is a brief overview. We're going to have a brief introduction of how this idea came to life, a little bit of what happened in Minera Fresnillo, in Minera Madero, Minera Saucito, and as Grant mentioned, some preliminary results from Minera Saucito, and the acknowledgement to all the people who help us to make this happen. In this picture, we see it's one shot from from Minera Saucito. We can see that it's a really clean mine site. That impressed us really. It was a shock for us, because we're used to see the mine sites like dirty places. But in this place, they even have a balcony with flowers, right?
Juan,
Yes.
could you speak a little louder, and could you speak a little slowly, please?
Okay. 2 times in a row.
So get the message, Juan.
Yeah. I'm a slow learner, sorry. So, where did this idea come from? Right? Last year in October, we had a seminar in which the students from JKMRC, we share what we are doing with our PhDs, and 19 students participated. It was a full day presentation. It was really, and Professor Lynch was here as well, and many people from the industry and also from the research center. They spent all day long here from 10 a.m. to 5 p.m. Listening to what we're working on. And as an outcome of this, I remember that Professor Lynch asked us, have you been on site? Some of us had that experience before, and some are students. And that was like the main driver to start this kind of approach, to start a trip, to gain experience for those students who might not have that experience in their background, and also to, if we were lucky enough, to collect some data for PhD thesis. So who received the students? The students were received by a company called Peñoles, which is also owner of another company, which is called Fresnillo, and now it's divided into different companies, right? Peñoles work with all the base metals, and Fresnillo deals with all the gold and silver mine sites from Peñoles. They have several operations located all across the country in Mexico. The owner of this company has managed to keep most of his business in Mexico. They rarely go in an international project, but now they have some explorations in Peru and Chile, and also they have some offices in Brazil and in the US. So we'll start with Minera Fresnillo. In Minera Fresnillo, the two students who were allocated there were Keaton Palan and Mario Corona, and Roberto Zarate from the research center collaborated with them all this time. This is a beautiful shot from the Fresnillo mine site in the afternoon after we finished the shift. So Fresnillo has been, in the past, Fresnillo used to be the main provider of the silver to the company, right? It has been growing a lot in the recent years, and is one of the oldest mine sites in Mexico. Here we have a picture of the team who worked there. The work that was carried out in Fresnillo was basically a combination survey and also a flotation survey. And interestingly, with this, we are now trying to get a model together to explore some potential alternative configurations for Fresnillo mine site, in which we want to create two parallel circuits, because here the recycle from the SAC 9 goes straight to the SAC 8, and hopefully we will make it happen. I'm not sure. Let's see what the model predicts at the end. Also, we were in Minera Francisco y Madero. This company belongs to Peñoles. This is a polymetallic ore in which they mainly produce a concentrate of lead, a concentrate of copper, and also a zinc concentrate. In Francisco y Madero, the students who were allocated there were Germán Figueroa and Yogesh Reya. Germán and Yogesh didn't have the chance to collaborate with one research fellow there, but they managed to do a great job anyway. Here we see Yogesh sharing his work with the superintendent of the mine site, Ricardo Aguilar. And Germán managed to get some measurements related with the turbulence, which is important for his thesis, and I hope that he used it somehow, because he made a lot of effort to get those measurements. Here we see Germán preparing his sensor with Yogesh and another technician from the company, and he tried different ways to get the measurements done. So what the deliverable for Francisco y Madero is going to be the mass balance and the final interpretation of the turbulence, if we manage to close that one. And finally, with Minera Saucito. In Minera Saucito, Erica Velar and I were working there for quite 6 or 7 weeks. And this is a picture of Saucito at 5:30, 6 a.m. That is the time when we used to arrive to the site. Minera Saucito, it's now the major, not the major, but well, it's the major producer of silver for Fresnillo mine, for the Fresnillo company. The interesting thing about Saucito is that they moved from the cyclones in the ball milling node and replaced them with the stack sizers, right? When we arrived to Saucito, the stack sizers were already implemented in the mine site, and also they have two parallel lines. We went into a negotiation with the superintendent and the metallurgist, and both of them support us to, at least for one day, take a snapshot with the cyclone in operation in the ball milling node. And like I told you, the mine site, it's impressive because it's really clean. They even have little trees over there. This is a picture that Erica took from the stack sizers. She fell in love with these things. And lots of people participated in the work carried out in Saucito. Not only the persons from the lab, but also some students from the Instituto Politécnico of Mexico and new people that were arriving to the company every day. So it was a pretty intensive work there. And now I would like to share some preliminary results and observations that we obtained from Saucito. The importance of being inside for students is because if we plan in the proper way, we can make a match between what we see on site with whatever we're doing in our PhDs, right? And Saucito, luckily for me, it was a really good base case scenario for my PhD with the comparison of the stack sizers and the cyclones. So going back into the literature review a little bit, the cyclone is basically a hydroclassifier in which we separate the fine size classes from the coarse size classes, but it's a hydrodynamic process. And in this process, it's not just a matter of the size, but also it's a matter of the density of the particles which are being classified. So sometimes we have some particles which might have a higher specific gravity than the overall feed, and they will deliver a different response in the classifier. And the stack sizer, this is a really interesting device. It's a positive classifier. Basically, the classification of the particles is related only in the size, most of it. And the way that the dairy company come with this device was to use a 5-way flow divider, right? They feed five screens stacked one over the other, and at the end they make a really sharp separation. So after we did the survey, we managed to collect some data, some historical data from the company. So now we had two goals with the survey. One was to try to compare the cyclone versus the stack sizer, and the other is to find an explanation of what happened with the change. Because when the company moved from stack sizers to cyclones, from cyclones to stack sizers, basically they were achieving an overall recovery of lead and silver. But when they make that change in the classifier, the response changed. They notice an increase in one of the valuable minerals and a decrease in the other one. So this graph shows the historical database that we collected there. It's almost around 1 year of operation. And we can see clearly that with the stack sizers, as soon as they start the operation, the increase of the lead went up of around 5 or 4% in average. And with the cyclones, the standard recoveries were less. The average recovery for lead with the cyclone is around 82, and with the stack sizer is 89. And what happened with the silver? Even when the mine site is built to, the final concentrate they sell in this one, it's a lead concentrate. The silver is an additional mineral that adds lots of value to the final concentrate. So when they moved from cyclones to stack sizers, yes, they managed to increase the production by around 30% in the throughput, which at the end deliver a more value to the final concentrate in terms of metal. But the efficiency in the flotation response was severely affected. So the silver the average silver with the cyclone was 84% recovery, and the average recovery with stack sizer came down to 78%. So as soon as you notice a change like that, the metallurgist is really compromised. Not only the metallurgist, also the superintendent, because they had to find or an explanation or a solution. Before going into deep detail for the comparison, the first thing that came to the mind is, are the feed grade difference between each one of the mines, between each one of the trains? So running a simple t-test pair for mean samples, we reached to the conclusion that no, there is no statistical difference between the feed grade that is going to every one of the trains of the comminution circuit. And also the same result we obtained the same result with the lead. So even when the grade is proven that the grade, as we increase the grade, we got more opportunity to increase the recovery. This was not the main driver of the change between the drop-off of recoveries. And we also built some simplistic regression models. And even when the adjusted square for the silver model is quite less, which is normal according to Tim Napierman, for models that built on site data, we got a really good regression for the lead. What does this mean? Here I'm showing the experimental recovery that we observe from the silver versus the predicted recovery we get from the model. This parameter, this one, the minus 6.3 times C. This is how we evaluated the effect of the classifier. When the classifier is 0, we are saying that we're using the cyclone. When the classifier is 1, we're saying we're using the stack sizer. So this means that independently of what happened in the circuit, right? Because I don't know if they changed reagent dosage or things like that. And I don't have also values of the tonnage going through the circuit. So independently of those parameters, every time I change the classifier, if I go to stack sizer, the silver is going to be effectively affected by around 6% in the final recovery. The same thing, the opposite thing happened with the lead, because every time we shift to the stack sizer, we're going to gain around 7% increase in recovery just by the change of the classifier. With the data from the whole year operation, we plot the particle size distribution for the cyclone up to 38 microns, and we have this shape. Then we plot the size distribution of the flotation feed with the stack sizer. And there is a slight sharpening in the final particle size distribution we're feeding to the system. And here we're inserting these blocks and circles to represent the particle size distributions that we measure during our survey. So when we got the classification efficiency, we were expecting at the beginning that after seeing this, we will see a dramatically change in the size distribution. Even when it doesn't look as dramatic as the change in the classification efficiency curve, there is still a change, right? So the blue line stands for the size distribution of the feed, of the flotation feed for the cyclone, and the red lines stand for the size distribution of the flotation feed obtained with the stack size. What happens with the lead? Due to the density effect that is being taking place in the cyclone, the size distribution of the lead is significantly significantly finer than the size distribution we obtain with the stack size. And the same thing happened with the silver, right? Marlowe, Weller, and Whedon have shown some of these effects relating the effect of the density in the D50, in the cut size of the D50, right? And interestingly is that the stack sizer enabled the operator to get almost the same P80 when we see the feed to the flotation It's almost a similar P80 of the valuable minerals. And with the cyclone, it's completely different. What is the impact of this in the preferential breakage? Here I'm trying to build up a little bit in what Kim Ranji presented a few weeks ago. She showed that if the classifier device is the same, independently of the cut size, a similar trend has to appear, right? So there is a lot of variability, of course, in the operation of the cyclone in this side, but the data we measure, which is represented by these red blocks, more or less falls on the same trend, right? This is the mineral preferential breakage for the cyclone, right? What happened with the stack sizer? The first stack sizer they installed in this mine site was a stack sizer with a cut size of 90 microns, right? When Erica and I were in Saucito, they changed the cut size of the stack sizer to 75 microns. So once again, it follows the trend that Kim showed 2 weeks ago, in which we see that we use a stack sizer with different cut size, but more or less the data fell in the same trend. So this enables us to assume that we can use the basin analysis to continue with some simulations and dig a little bit deeper in the data. The same thing happened with the silver. This is the data we measure during the survey compared versus the data of the historical database from Saucito. Again, follow the same trend. And the stack sizer with 90 microns stack sizer follows the same trend than the stack sizer with 75 microns. What we actually see in this comparison? We see that we're trying to get the same recovery with two complete different conditions in the valuable mineral. Here is a comparison of what we actually measure during the survey, which is the cyclone with the lead with the cyclone and the lead with the stack size, right? It's completely opposite. And the same trend happened with the silver. What does this curve mean? If we go far away from this line, we're saying that we have an increase in the preferential breakage, right? Whereas if we go closer to this, or to the left side of the curve, we are saying that the preferential breakage of the particle of the mineral of interest is less. Before moving a little bit forward, so far we have seen data processed until 38 microns, but we have to go further because the size distribution and the values were not complete with the 38 microns. So the only option we had to process the data there in time was to use a cyclosizer. So I apologize in advance for the weird hook that we're going to see in the data. I blame the cyclosizer, and I hope that as soon as we check the method that will be proposing his thesis for the correction of the size distribution with the cyclosizer using MLA data, we can fix it. So we're moving to the recovery by size. What actually happened here? Because this might be this is actually the response to everything else. The recovery is a function of the recovery per size class times the amount of mass that we allocate in each class. So here I'm showing this recovery by size curve was filled with the historical data we have from Saucito, right? And the confidence intervals were built with 95% confidence using all the database. And this is the comparison of the recovery by size that we obtained with the cyclones using the same approach. All the files that we have in the database and a 95% confidence interval. So what we can see here is that there is a huge difference between the recovery in the core size fractions when we move to the stack sizes, right? We can say that the drop-off in the fines more or less might be similar because the confidence intervals of both of them fall into each other. But this is a really interesting change. So when we compare the lead with different cut size, first they start the operation of the stack sizer in one of the combination circuits, right? And then they start the operation in the second circuit. But they only use it for 2 months. So this is an average recovery by size of only 2 points, which is not good. That's why it doesn't have any confidence intervals, right? But more or less fall within the same ranges. But when they change to the 75 microns stack sizer, again, we notice a change in the recovery by size curve, which is at the less recovery of the coarser size fractions. We need more points to actually say that this is a real statistical difference between these two, right? But it's what we have at the moment. It's an assumption. And the other one is that the fine size classes more or less recovered in the same values, right? Then what happened with the silver? There is no problem if we increase the lead because we moved from 85 to 89. But the problem was the silver because we moved from 84 to 77. So with the silver, we have this trend when they start the operation with the stack sizer. And here is the comparison of the recovery of the silver with the cyclone. We can argue if the recovery by size more or less looked similar, except for the change again in the core size fractions, right? And this is the recovery by size only with the stack sizers. It's the same trend. They start the operation in the first plant with 90 microns. They start the operation in the second plant with 90 microns, so the trend is exactly the same. But with 75 microns, there is a really interesting trend here. We see a drop-off in the core size fractions, but we notice an increase in the fine size classes, right? So we will expect that an increase in the recovery. How to explain this in both languages, right? I'm in a really difficult position as a PhD student because I have one pair of advisors who are only comminution and they only care about hitting the rocks. And I have another advisor who has worked many years in flotation. And she doesn't care about how you break the rocks. She just cares about the recovery by size. So it's almost as difficult as to choose what to eat, a hamburger or an apple. Who's best, Ronaldo or Lionel Messi? This is me every time I discuss with them about what I have to do with my thesis. See the drama on it. Okay, be patient in this sense because this trend is, we're trying to get to a similar language, right? In this trend, what I want to show is the size distribution versus the recovery to get the recovery by size and the size versus the percentage passing of the flotation feed. So if we plot the recovery by size with the stack sizer at 75 microns of the lead and the recovery by size of the lead with the cyclone cutting at 58 microns. And we have the flotation feed, which is this line. This is the blame of the cyclosizer, right? That's where we need to improve a little bit this curve. And this is how the actual lead is moving. When we finish the comminution, the breakage in the comminution, we will send everything to the classifier, and this is what we are sending to flotation, right? And this is what we send when we have a cyclone in operation. We send a final size distribution in the overall feed, right? but we also are sending a final size distribution of the lead, right? So if we compare the lead only, we see a clear difference in P80 caused by the density effect of the classifier, and this will obviously give us a different response. So if we take all the mass here, we will expect more or less a good recovery. But whatever falls into here, we're going to have a really low recovery, right? So interestingly, if we were able to sharpen even more the size distribution to allocate all the masses, independently of whatever device we're using, into the right flotation range, we will expect to see an increase in recovery. And this is the version for the mid-lobers, right? Is the same recovery, but is a recovery by size of the lead. So in the red line, we're seeing the recovery of the lead with the stack sizer at 90 microns. And in the green line, we're seeing the recovery of lead with the stack sizer at 75 microns. The blue lines represent the recovery of the lead with the cyclone cutting at 5800 microns. What happened when we moved from cyclones to stack sizers is that we stopped allocating the mass of the lead in the fine size classes and moved them to the coarse size fractions, right? But it gave a really good response because of the increase of the recovery of the coarse size fractions. With the stack sizer at 75 microns, more or less we end up having the same distribution of the mass of the lead in the coarse size fraction, and we diminish the amount of fine particles here. I think that is one of the explanations of why the lead got an increase in recovery. The same thing, we're going to do the same exercise with the silver. We have the 75 microns stack size, recovery by size, and the 58 microns stack size, the 58 microns recovery by size with the cyclones. So we put the flotation feed here of the stacks of the feed generated with the stack sizer. We notice that we're allocating lots of particles in a range in which the flotation, the recovery by size is not as good as it will be in the fine size classes. Whereas with the cyclone, due to the density effect, the silver gets into the circulating load and it's being grinded more times, right? So the particle size distribution of the silver with the cyclone is usually final. And we allocate these particles in the right range of flotation. So again, with the 90 microns recovery by size, 75 microns recovery by size for the stack sizer, and the recovery by size for the cyclones is the same thing. More of the mass is being allocated with the cyclone in the good recovery size classes, whereas with the stack sizer, we send more of the masses, which might be a little bit evenly distributed or better distributed than the cyclone. And when we allocate more mass in these core size fractions, even when we have an increase in recovery, we're losing the mass here, where we have the best recovery scenario. So I also think that explains why we lose the silver. So finally, we reached to some preliminary conclusions and observations. The historical data from Plant 1 and Plant 2, as well as the preliminary data generated during the survey, was used to determine the feed particle size distribution of the available minerals, and the comparison of the stack sizers and cyclones in terms of recovery by size of lead and silver. The regression model for the lead and silver indicate a clear effect of the classifier in the final recovery of both. If cyclones are used to classify prior flotation, the valuable minerals take advantage of the gravity and density effects occurring on the classification stage, leading to a preferential grinding of the valuable minerals. If stack sizes are used, diminishing of production of fines in the overall flotation feed is achieved, but it also produces less preferential breakage of the valuable minerals. The coarse lead and silver recovery is observed to improve when the stack sizes are used as the classification device. The mass of silver allocated in the best recovery by size fraction is higher when we use the cyclone, and therefore the final recovery of the silver obtained with the cyclone is higher, which is 84%, compared with the 75% recovery obtained with the stack sizer at 90 microns, and an 82% obtained with the stack sizer at 75 microns. Something I have to clear here is that we only have 1 point of this measurement. So I cannot say with true confidence that this value is real. So maybe it's going to be higher or maybe it's going to be lower. But the cyclone and the stack sizer at 90 microns, both of them have many data points. So overall, the lead recovery improves and the silver recovery decreases after they move to one classifier to another. So we reached to the end of this seminar today. I hope it hasn't been that boring. So I want to publicly acknowledge to many people, and I think I'm gonna take more time in this slide than in all the presentation. So from the Peñoles and Fresnillo side, I would like to acknowledge Dr. Pablo Gonzalez, who is still concerned because I haven't learned how to plot the graph properly, to Salvador Gomez, Ramon Alanis, and Daniel Aguilar, who helped us to get the approval from the Peñoles and Fresnillo side, to Angel Sanchez and Roberto Zarate, to collaborate with the students during the surveys, to the Wolfpack, who is helping us with all the assays. From JKMRC, there were a lot of people involved in making this opportunity happen. So I would like to thank the director Alice Clark, the Professor Alban Lynch, and the Professor Tim Napperman. The three of them at the beginning of the idea were really supportive with everything, and they actually helped us a lot to make it happen. The Dr. Elaine Whiteman, Jacqueline Ross Hagenbaum, Tess Dobinson, Tammy Dare, and Sharon Brundle, who helped us with all the paperwork that we need to deliver to the site and to the unit. To the people who were in contact with us when we were in Mexico, the Dr. Kathy Evans, Dr. Kim Ronji, Professor Malcolm Powell, Graham Valentine, the Dr. Graham Valentine, and the Dr. Amy Manlapik, who every once in a while also Alban Lynch was in contact every single day with us using Skype. So thanks a lot, Professor. And the persons who visit us, David Way and Sebastian Tello, while we were in Mexico. And of course, I have to thank the Dr. Tuyen Nguyen, who trained me during the survey in Cannington, in another mindset, sorry, for the advertisement. And the Dr. Stephen Larpy Brand. And I forgot to include your name, Tim. You helped me a lot as well. From Madero, Germán and Yogesh would like to thank Ricardo Aguilar, Jerkin Lopez, Antonio Moreno, Ricardo Raudales, the engineer Salas, y Eric Delgado, y Carlos Uriel. And from Fresnillo, Kate and Mario would like to thank Jaime Bravo, Concepcion Quintero, Luis Carrillo, and the students from the Politécnico. And in Saucito, Erika and I would also like to thank to Roman Cruz, Nestor Alvarez, Araceli Núñez, Ariadna Manrique, Jesus Alejandro Victor, and the students from the Politécnico. And one final acknowledgement, which I think is also really important, for those who are married of us, to our couples. They were really supportive during this period, to the family and friends. And that's it. Thank you for your time.